Hi, this is Mike Keenan. Today I want to go over IPSec VPNs, just give a broad overview of how they work. In this topology, we have the 10.1.1.0/24 subnet. And up here we have the 10.2.2.0/24 subnet. So orange subnet and yellow subnet. Now, what these things could represent is they can represent an organization, or they can represent a company, they can represent all kinds of different things. We're going to say that this represents company A. And up here, the yellow, that's going to represent company B. So company A and company B got together and they decided that they need to form an IPSec VPN over the internet. They want to do that because they don't want anybody in between on the internet down here. They don't want anybody on the internet to be able to look to see what's going on. It could be credit card transactions, it could be sending email, it could be any number of things, but over the internet they don't want anybody to be able to look in to see what that communication might be. So what they want to do is form an IPSec VPN tunnel. So what happens is communication over here, and I'll just use company A as an example, and we'll say everything that's here to here is unencrypted. We'll say that it's plain text. So if you were to look in here, look in that wire and see what's going on, you would see the plain text HTTPS traffic, your web browser's traffic reaching out to the internet. You would see your email traffic going out to the internet. It would all be in plain text. However, when it gets here to the untrusted zone, and it's untrusted because we don't have control over the entities or the equipment that's out here on the internet. It's kind of like the wild, wild west. So we want to make sure that it is fully encrypted in a VPN tunnel. Now, even though that's untrusted over here, this is what we call the trusted zone. At least for company A, this is the trusted zone because they have locks on their doors, they control all of the network equipment, they have full control over what happens within their environment, full physical control. Once it gets out to the internet, they don't have physical control, so they want to form an encrypted IPSec VPN tunnel. So what does that look like? Well, if we were to look here, like I said before, this is all plain text, so we're going to color all this in as blue. That's the plain text. And once it gets out to the internet, we're going to color it red because it gets encrypted. So it's a tunnel that goes from this interface to this interface of company B. And anything traveling between company A and company B is all encrypted in this IPSec VPN. Here. So remember, encrypted, not encrypted. And then once it gets here, it gets unencrypted and sent back to the web server or to the email server, or whatever the case may be, that company A needs access to. And that information is decrypted by its VPN appliance. So I should cover that. I should say this is a VPN appliance for company A, and this is a VPN appliance for company B. This is a Cisco ASA firewall, and this is a Cisco iOS router. So let's look at what that looks like on the wire. So what we're going to do, I have a couple captures set up here on the wire. I have one here, and I have one here. We're going to actually take a look and see what's going on in that wire to see if it's encrypted or if it's unencrypted. So again, over here, all of this is going to be your plain text unencrypted. And we're also going to look here too as well. So here is going to be encrypted, and here is going to be unencrypted. So as the traffic goes through, hits the firewall, it matches what's called an interesting traffic ACL, and it knows to encrypt that traffic. And instead of sending it straight out over the internet, instead it's going to send it out over the ASA, over the VPN, to the internet, to site B, to customer B. He'll unencrypt it, and send it back to the computer, the server that's over here, and then the computer will respond. It'll get re-encrypted and sent back over the internet and get decrypted by Site A's VPN appliance, and then make it back to whatever host. This could be a workstation, this could be a printer, it could be some application running on a server, whatever the case may be. These two guys, for some reason, they need to talk to each other, and we want everything in the middle on the internet to be secured. So let's consider everything that the VPN offers us. It gives us 1, confidentiality, because it's encrypted. 2, integrity, meaning we know that the information is exactly the same once it leaves Site A and once it arrives here at Site B. And it also offers us authentication, because there's something called a pre-shared key that is known by both sides. Depending on how you configure it, it also is authenticated by the source IP address as well. So in this case, this one is 1.1.1.2. Over here is 2.2.2.2. So if this VPN appliance over here at Site B, customer B, it knows only to respond over the VPN to customer A at 1.1.1.2. So now we're going to look inside the wire to see what that looks like exactly. So we have this capture here, which is between switch A and Site A. And we have this capture here that is between Site B and the internet router here. Now we've already got an association here between Site A and Site B. You're already going to see the ISACAMP packets and the ESP packets, but just pretend like those aren't there for now, and we're just going to generate some traffic to see what it looks like. So here we have we're logged into this computer here at A1, and what we're going to do is we're going to pull up a web browser, and this is actually over here. This is a web server. Even though it looks like a workstation, that's a web server. And what we're going to do is go to that web server's website. Now when I type this in, pay attention to what happens in these captures. So you see here, I've gotten web server B1's HTML page. That's him right there. And I can also go to 16 as well. And that's B2. So I've hit B1's web page and B2's web page. And let's see what it looks like on the wire. Well, over here you can see HTTP. That's the Hypertext Transfer Protocol. If you see that, you know that that is unencrypted plain text traffic. If it was HTTPS, it would be encrypted end-to-end, but in this case we're dealing with HTTP. So anybody that's in this environment within customer A's environment will be able to see the plain text information of what's being sent over the wire. But on the internet, you see we came here, and this capture is out on the internet, and what you'll see are ISACAMP packets and ESP packets, and both of these are encrypted. They're encrypted transmissions so that nobody on the internet can look in there and see what's going on. And then finally, pull up the last capture here. This is at Site B, customer B's environment, and this is the capture that's running right here. So you can also see here, it's also unencrypted HTTP transmissions. So I hope you enjoyed the video, I hope you learned something, and I hope to see you in the next one.